Okay, so chapter 7 is about your, indeed a very important chapter as well, because for the past, I think 3 years, 2 years, 3 years, chapter 7 and 8 is not out for almost 3 years, I think, if not mistaken. So yeah, these last two chapters are actually quite important. Okay, so chapter 7, it's about synthetic stuff, means like man-made stuff. Okay, everything you learn about, actually there's only two things, synthetic rubber and synthetic, no, not synthetic, I mean plastic. So synthetic rubber and plastic, so only two things or two items. Okay, all these are made by combining monomers into polymers. So polymer, okay, synthetic polymer are chemical compound that contain long chain molecule, okay, that are made up of small molecule unit, okay, made up of small molecule unit called the monomer. Okay, so when we combine a lot of monomer together, it becomes a long chain called the polymer. So the process is called polymerization. I'm pretty sure you all still remember this in Form 5 Chapter 4, right? We did talk about a little bit about this. So by going backwards, that's also very easy. Depolymerization. Okay, depolymerization. Yeah. So rarely we do this one actually. Most of the time it's polymerization, because man-made stuff, right? We always start off with monomer. After we have a lot of monomer, right? We do satay lah, you know, satay like that. Okay, so we have all the meat and then we will skewer them through to form a long chain called a polymer. So a lot of pieces of meat become a satay, okay? And by eating the satay and pulling the meat off, depolymerization. That's for example lah. Okay, can. And so these are some of the monomer and polymer names that you probably have to kind of memorize a bit. So for instance, if like question asks you like, oh, what is polythene made up of? Oh, polythene is polymer. It is made up of ethene. Okay, not like super important, but just in case I do questions like objectives, they sometimes ask very detailed stuff, very small stuff. If you don't remember, then that's a bit risky. Okay, so all these are man-made stuff. It could be plastics, it could be rubber. So these are plastic. These are rubber. Okay, but we will talk about in detail in a while actually to split them up into two groups. So as for now, you're okay with the basic, right? I think we can try out the exercise. So please turn with me to page 23 lah, like 23. Okay, so like first thing first, what are synthetic polymer? Okay, definition of, you kind of have to remember those. Synthetic polymers consist of long chain molecule that are made of, yeah, so go ahead, number one, everyone, okay? Okay, all good, shall we? Right, name process X. Okay, very easy, making satay. We have a lot of small one, and we combine. Okay, so polymerization. All right, and then number C, please match up the number of monomer inside. Okay, this is very easy also lah. So polymer P, there's only one kind of shape, right? So basically that's one type. Okay, and if you see satay number 2, you have like maybe meat You have daging, and then you have like timun, and then daging, and then timun. So then there's two types, two kinds of shapes. So please draw the lines for C. Okay, we will go to donkey. Give one effect of improper disposal. Improper disposal of synthetic polymer means like rubber and plastic. Improper disposal means usually we talk about burning. I mean, what else method you can settle or throw away, settle the rubbish of like plastics and rubber? So mostly people burn it lah. So that will actually simply cause air pollution. Okay, so you can write that as causes air pollution. Okay, causes air pollution. As simple as that. 1 mark only. Okay, I don't know why there's 2 lines, but so you can just write causes air pollution. All right. Okay, so question E, shall we? 2 proper way of dispose. Okay, very easy. This is not something fancy. It's actually from the chapter itself, but all the way backwards to how to settle plastics, and all that. Okay, so I always remember these 2 very simple answer, which is 5 and 6, but not the whole thing. So I think the most practical way that everyone can do, right, is to recycle and reuse. I mean, the birth of plastics, you can no longer reverse the process. They are there, like straws, for example, they are there. No matter you use it or not, straws are produced. You cannot reverse the process. So straws are in the market. I mean, when the demand is lesser, the supply is lesser, so we have the power actually. So nowadays we don't use straw, we all take the step where, okay, no straw. So when we don't use straw means the restaurant doesn't buy straw. So when restaurant doesn't buy straw means the straw factory doesn't produce straw, then we probably don't have straws anymore. So you can't really reverse it, but what you can do is recycle plastics that you can recycle and keep using it. All right, not like one-time plastic. You can probably like food container, you can use it for a lot of times. Okay, and also if you really need to burn in the incinerator. We did talk about this in Form 5 Chapter 3. Remember a few weeks back? We talked about incinerator for burning things. That's a place, or that's like a house, or that's like a factory to filter dirty smokes or toxics before release into the air. So I think I will go for 5 and 6, but we make it shorter. You can write burned plastic waste in incinerator. You kind of have to rearrange this. Yeah, can you rearrange? Okay, burned plastic waste product in the incinerator. Number 2, you go for this recycled plastic waste products. Okay. Can okay, so number 2, okay, number 2 no need. So done E, okay, everyone done. So I think we'll come back to the notes. We okay, we go for rubber, synthetic rubber, man-made rubber. So man-made rubber, right? It's a vegetarian food. Any vegetarian here? You know how vegetarian food, I mean, it could be 100% veg, but you know how sometimes how vegetarian imitate meat, like meat dishes. There's no meat inside, it tastes almost the same or sometimes exactly the same, and then the texture feels the same as well. That's basically a very good copycat, of food. Or same goes to synthetic rubber. Synthetic rubber are man-made rubber, which does not contain any rubber at all, but it is as good or not, it is better than natural rubber. Natural rubber comes from the rubber tree, like latex. We talk about this in chapter 4 from 5. But synthetic rubber has none of that at all. Like, it's totally fake, but it is as good or not even better than natural rubber. Okay, so that's basically how we understand this. Yeah, so synthetic rubber are made like that. So synthetic rubber are made from hydrocarbons. Yeah, actually all man-made stuff comes from hydrocarbon. Okay, and what is hydrocarbon? And this is also from your form 5 chapter 4. Hydrocarbons are things that consist of hydrogen and carbon only, right? Hydrogen and carbon, remember? So we have only 3 examples, such as petroleum, okay, natural gas, and we have coal. Yeah, do you remember this? That's from chapter 4. So man-made stuff are all made from all this. All right, no problem. Okay, okay. So these are the 4 examples that we have. So please remember the example. Like, there's only 4, not very difficult. Those are very common materials that we use in market now. If you heard of them. So neoprene is a very versatile rubber that used in many areas, because neoprenes are generally just so good. They are heat resistant. They do not burn easily. They can tahan oxidation. They can tahan sunlight. They can tahan oil. They can tahan chemical. Basically, they are good in everything. So basically, it is being used in so many products or areas. Okay, SBR are only good in vulcanizing. So it's only for car tires and shoe sole, the bottom of your shoe. Vulcanize means, remember chapter 4 also you learned, where rubber can be heated with sulfur to make it a bit stronger. So that's called vulcanization. So SBR has the ability to keep doing it. Like, not strong enough, not happy about it. Okay, I make it stronger for you. Then make already, then you try. Still not good. Not happy. Okay, I make again. So that's the property of SBR. So it's very suitable for car tires and shoe sole, the bottom of your shoe. Okay, Tioko is good for chemicals. Tioko very tahan chemical, so it's very good for like tanks, oil tanks. Okay, silicone rubber, heat resistant, so it's good for car and vehicle or aircraft parts. All the engine parts, all the gaskets, the rubber parts of it. Okay, there's only 4 types. Yeah, so try to remember the names, their specialty, and what are they going to make of. Okay, so that's it. And the good thing about all these natural synthetic rubber advantages are actually mentioned here in the property, and also actually we're gonna do the summarized version in the box lah. Okay, why synthetic rubber is so good? Basically, synthetic rubber is very good in resisting heat, resisting chemical, tahan oil, tahan sunlight, tahan oxidation. Basically tahan everything. Yeah. So synthetic rubber is heat resistance, more resistance to chemical substances, as compared to natural rubber lah. Okay, and then on the other side, natural rubber is soft, good sound absorber, and good vibration and shock absorber. So often your advantage is actually your disadvantage. Your disadvantage is actually your advantage. So being lousy, not able to tahan heat and soft, right? But actually that's your advantage. You're able to absorb sound and shock and vibration. Being hard and strong and able to tahan this and tahan that, right? That's your good side, but that's your advantage. That's also your disadvantage. you're unable to absorb shock and sound. So we actually kind of combine natural rubber and synthetic sometimes to make like, I don't know, like tires, most probably. Okay, so we have the best of both worlds. Okay, so natural rubber is elastic and easy to be stretched, like rubber band like that. Synthetic rubber is very difficult. Like, I mean, try and stretch your shoe sole, like the bottom of your shoe. You can't really stretch it, right? Yeah. So, and to remind you about chapter 4, we have something called vulcanized rubber. So we have total 3 kinds of rubber now. If you feel confused, so let me clear this up for you. We have 3 rubbers: natural rubber, vulcanized rubber, synthetic rubber. So in sequence, lousy to good will be natural, and your vulcanized, and your synthetic. So natural rubber is totally pure latex. Synthetic is add on sulfur to make it stronger. And vulcanized. Did I mention wrongly? Vulcanized. And synthetic is 100% man-made. So if you were to put into an analogy, right? Natural rubber is like Tony Stark. Tony Stark, you know, the Iron Man character. It's pure human. He himself is just a normal human, other than being like super rich. Okay. Vulcanized rubber is Iron Man, means still Tony Stark, still natural rubber, but we add on sulfur to make it a bit stronger. We add on the Iron Man suit to make it a bit stronger. That's vulcanized rubber. It is still vulnerable. It is still human. He still dies. Okay. Synthetic is like transformer, 100% non-living thing. It works exactly like how human can fight, can run, can do all whatever it does, but there is no human at all. It's purely robotics. Okay, you get what I mean, right? So synthetic is 100% man-made, vulcanized is the middle, and natural is the lousy one. Okay, so in your experiment, right, they won't ask 3 at the same time one. In your chapter 4, they will compare the natural rubber and vulcanized. You know, the last question where we hang the weight and let it pull and measure how much it pulls. That's the elasticity experiment. That's natural versus vulcanized. For this chapter, it will be natural versus synthetic. So it will always be Tony Stark versus Iron Man, or Tony Stark versus Transformer. There will no Iron Man versus Transformer, or there will be no vulcanized versus synthetic. Usually no. It will be 2 different separate experiments. Okay, I would like you to turn with me to your exercise all the way backwards to page 29, question 9, 29, shall we? Okay. Nurin, I have checked for you. Is it you who got it? Yeah, I think it's you, Nurin. I've checked for you about your GC. Apparently, let me see. Apparently, they didn't remove you from the GC. I think something wrong with it, or you accidentally exit. So there's no issue. I think they re-invite you again. So later you have to check your Gmail and masuk again. Yeah, Noreen. YN, this is page 29. Okay, got it. Okay, so wait, I was saying, yeah, then this is the famous question, right? The having weight on it and then it pulls and we see how much they extend, that determines elastic or not elastic, can pull or cannot pull. Okay, yeah, you're welcome. So you check your Gmail later, like maybe the spam or the inbox. So no issue. I think something went wrong, or it could be a accident. Okay, so a rubber strip was stretched by the load of 100 grams. The extension of the strip was determined by measuring the length of the strip before and after the stretch. So we're going to measure before and after, you know, before we hang, we measure one time. After we hang 100 grams, we measure another time. The experiment was repeated by replacing the strip of natural rubber with a strip of synthetic. So we are testing between elasticity of natural and synthetic. Tony Stark and transformer. Okay, like manipulated responding, and I like easy, cheesy, lemon squeeze. Your choose or your copy from the box below, the result below. Okay, like for you, everybody. And constant, and that's very straightforward as well. Okay, so manipulated copy free from the table will be type of rubber strip or type of rubber. Okay, and your responding will be, okay, so this is the case. So you might be thinking, hey, can I write like final length? Okay, no, because final length is not what we're looking for. We're looking for extension, right? Yeah, the extension of the strip was determined by so we want to measure how much it extends. I don't care what's your before or what's your after. I just want to know how much you have extended. Yeah, so that's basically we would like to measure off. Okay, Ken? So your responding, I would suggest we go for extension of the rubber strip. Okay, extension of the rubber strip. All right. Okay, manipulated done type of rubber extension. Okay, constant variable obviously will be the mass of weight. How heavy must be 100 and 100 grams. Fair for both, so that will be your constant variable answer. All right. Okay, cool. So next page, please. Question B. State the conclusion that can be made from the experiment. Like, oh, okay, what do you learn from this? Oh, I have learned that actually natural rubber 4.5, wow, so easy to stretch one. That means natural rubber, right, is more elastic, isn't it? We're talking about elasticity now. So your conclusion will be talking about elasticity as well. Okay, so like everybody, your conclusion will be natural rubber is more elastic than synthetic rubber. Okay, more elastic than synthetic rubber. Okay, no problem. Okay, so like state one other characteristics of natural compared to synthetic. Okay, we choose from the table. So other than last one cannot write, Liao. You may choose the other that you want to write. Up to you. Like natural rubber is a good sound absorber, while synthetic rubber is a poor sound absorber. I don't know. Up to you. Like synthetic rubber is more heat resistant than natural rubber. So you choose one. Okay, you want to write absorb sound also can. You want to write absorb vibration also can. Chemical also can, but not the last one. You make your own sentence. You okay? Try and form. Yeah, Amelia, yes, absorb sound. Absorb, how you spell absorb? Why so many D on? But yeah, absorb sound is good answer. Or the rest also can. Okay, all good. Okay, so let's continue. Oh no, I think we'll come back to the notes. We're done for rubber. That's it, very easy. Okay, and we go for plastics, the next type of question. 7.2, plastics. Definitely man-made. So hence we don't have to like have the word synthetic. We just have to say like, okay, plastics, then we all know. That's man-made, okay? There's no natural plastic anyways. So there's two types of plastic lah. I'm sure you all heard of that already. Thermoplastic and thermosetting. Thermoplastic is the lousy one. So we have names here where you have to memorize. All starts with the word poly should be thermoplastic because they all start with P. So remember P plus P. Also plastic, also P, thermoplastic. Okay, so we have all start with P. Polymers. Bad. Those are lousy plastic, I can say. Okay, no, I shouldn't say lousy, but like weaker plastics. All right. So thermoset are the stronger one. We have 3 only. Bakelite, melamine, epoxy resin. You have to remember. Keep reading this for a few times. Like just go through this. Okay, polythene, polypropylene, polystyrene, polyvinyl chloride per spec, polythene, polyvinyl chloride, polystyrene, and so on. So keep going on. For the other one, bakelite, melamine, epoxy resin, bakelite, melamine, epoxy resin, bakelite, and melamine, epoxy resin, and the products as well. Roughly, you have to remember them. Okay. Why thermoplastic so lousy? Because no cross linkages. It is made like that lah. There's no cross linkages. So since there is no cross linkages in between, the polymer will glide onto each other easily. Okay, and the thermoplastic material easily soft or melt and can be remolded. Okay, can be remolded. It sounds lousy, you can melt one, you soft one, you. But remember, your disadvantage is actually your advantage. Being soft is not something bad. That basically means that you can recycle, you can reuse the plastic. Okay, although it's soft and it melts easily, but the good side is where you can recycle it. Okay, it's a recyclable plastics. Where on the other hand, thermosetting has cross linkages. Okay, so cross linkages prevent polymer chain from gliding. So it can only be molded only once you choose the shape, and you will be that for the rest of your life. Okay, will not soften again. Okay, so cannot be recycled. Yeah, I know you're very strong, your advantage. Hard, strong, cannot melt. But too bad, you're a non-recyclable plastic. You can be only used one time. Okay, can? Right, so that's how you draw as well, okay, cross linkages. So the conclusion of all the characteristics we have here. So high melting point, low melting point. Cannot be remolded or recycled, can be remolded and recycled. Yes, cross linkages, no cross linkages. Cannot dissolve in chemicals, can dissolve in chemicals. Harder, softer. Higher resistance to shock, lower resistance to shock. Okay, don't confuse. Higher resistance to shock means cannot break easily. Cannot break easily because they are very strong plastic. If any vibration happens or any collision happens, it doesn't break easily because they are strong. Okay, while this one lousy, break easily because no cross linkages. Yeah, so these two kind of connects together. Okay, don't confuse the reason. Okay, heat, higher heat resistance, lower heat resistance. Yeah, so very simple. Okay, that's it. Very easy topic. So let's come back to page 25, everyone. Page 25. Question number 4. Okay, we have 8 products here. You're supposed to categorize them into rubber, plastic. Okay, this is like a summary of all three products. Rubber, we learned just now, remember there's 4 types, right? Neoprene and so on. Plastics, we just did 2 types of plastics and there's more examples. Okay, we don't learn synthetic fiber, but very easy one. Synthetic fiber means man-made fiber, like our clothings are made of. You're actually wearing petroleum, by the way. if your clothings are made of pure cotton, then yeah, that's natural. But I mean, let's say what I'm wearing now is like a jersey material. It's a polyester. Yeah, it's not cotton. It's man-made stuff. Okay, so fiber is for clothing. So I would like you to split them into the groups. If you're wondering where to find out, those are the products we have here. Look out for products. Okay, and rubber products are in front there in this gray table. So help yourself. I think I want to stay this page. Can, like everyone, for you are A, 1, 2, 3. Separate them into groups. All right, shall we? Okay. First one, polypropylene chairs. You know the school chairs that you all sat on? Those are polypropylene, like mama or kopitiam, those chairs, okay? That is definitely plastics lah. Perspex shower screen. Perspex is under thermoplastic, of course, it's under plastic. Electric cable insulation, that's a rare. That's a rubber, man-made rubber, synthetic rubber. Nylon stocking, you know, the female kind of stocking, the one you can pull all the way up to your thigh, okay, the long stocking. That's fiber, synthetic fiber, okay? Clothings, right? Rubber boots, of course, rubber. Car bumper, it's under bakelite, it's under thermoset, it's under plastics. Polyester necktie, polyester clothings, that's synthetic fiber. And water hose, rubber, of course. So rubber, there's 3, rubber boots, electric cable insulation, and water hoses, okay? Plastics are the rest. Synthetic fiber, there is 2, nylon stocking and polyester necktie. Is everyone okay? Yep. So fiber got 2, synthetic rubber got 3, the rest is plastics. Okay, let's go to question B, shall we? Okay, what makes Perspex more suitable than glass in manufacturing shower screen? Actually, we kind of replace glass with Perspex nowadays. No matter if it's shower screen, or if it's like your spectacles, the glass of your spectacles, the lens of your spectacles, the window of the aeroplane or our car, we all kind of replaced it with Perspex. The reason because Perspex is a plastic, by the way. It can actually imitate glass as good as glass, or if not better, you know. The real reason behind it is because glass can break and shatter, you know, when glass falls, Perspex does not. So especially shower screen in your shower, in your bathroom, it's very dangerous if the glass actually breaks. You know, sometimes you might slip off, very slippery, and then you kind of hit the glass door and bang, but Perspex doesn't. Perspex is plastic. It's like your spectacles lens, those who wearing specs, you take the lens out, you try to step on it, it will not break one because it's very flexible. But glass confirm crack. Okay, so that's the reason why we replaced it. So this is a bit lurbe from what we learned, but it's good to know now. And that's the reason behind it. Okay, so you can write Perspex does not break and shatter, and then a lot of small pieces. That's called shatter. Okay, so there you go. Alrighty, next one. What characteristics of nylon makes it suitable to manufacture ladies' stocking? Nylon, why good for stocking? You know, when you buy the stocking, ladies' stocking, you buy that time, right? It's like a small kids stocking. But wow, metal you wear, you can pull all the way up to your thigh. That means what? That's very if you don't like to wear on your leg, you can wear on your head also to rob the bank. You know, if you want to rob the bank, just wear one on your head. It's very flexible, right? So I mean that it's called I will talk about elasticity. Did you go try before? Which one you mean? Rob banks or wearing it? Wearing it? No. Rob banks? Yes. Not joking. Did I? I don't recall, but I don't recall I wear it on my legs, but I wear it on somewhere else. Ding. I wear it somewhere else. I wear it on my head to rob the bank. Joking. Anyway, it's getting lame. So no, I don't recall I wear before. But the book say elastic, then I might teach you elastic. I teach what the book teaches. But you know, you all watched movie before, probably your mom has one. Maybe try and ask like, mommy, you have the rock band one, then your mommy give you, then you try and wear on your head. But your mom wear it on her leg, but you wear on your head. Then not good, you wear on legs. Okay. So, and very elastic. Yeah, that's the I mean the reason. Okay, like so nylon is very elastic. Okay, right. D. Name the polymer to manufacture car bumper. You have to remember products. Just now I think when you all flip through the notes, you all find out already, right? Car bumper belongs to. Do we have just now? Oh, we have you all should already know. Car bumpers belongs to bakelite. I think question is asking for the name of the polymer. Yeah, you shouldn't be writing thermosetting plastic. You should write the name of the polymer or the plastics that make car bumper. So that's called bakelite, everybody. Okay, bakelite. No problem. Okay, we're gonna jump a bit to C, which is the next question. Just turn around to C. We will draw I just wanna help you all recall how to draw. Then we move on to next one, yeah. Okay, so thermoplastic, the lousy one, no cross thing, so straight one. So just draw any kind of pattern you want. Okay, make it simple. And make sure you draw the polymer. Is that all right? Right. So thermoset. yeah, cross a bit, okay. Like that, a bit, something like that, or maybe like a few more. Yeah, okay. Then the polymers are where they are at, crossing each other. You can add on a bit to fill up the space. Yep, there you go. That's how you draw. You want to draw like the robot below also can, but I don't really like to draw this because you need to use ruler. I don't like using that to draw. There you go, everybody. You okay with drawing? No problem. Cool. Let's continue with actually question 6. Okay, question 6. Shall we? Okay, now obviously you already know the type of plastic by looking at the picture. So this is thermoplastic, this is thermosetting plastic. Okay, so like why not you write your answer for A? Okay. Okay, so no problem. Number B, state a similarity between thermoplastic and thermoset. Thermoplastic and Y is thermoset. Yeah, so X is thermoplastic, Y is thermoset. That's correct. And question asking for one similarity though, one similarity. Okay. Oh, by the way, don't just write thermoset only. You must write thermoset. I always say thermoset because I'm lazy to like mention the whole thing. Thermosetting plastic, everyone. Sorry that I always just say thermoset. Okay, should be thermosetting plastic and thermoplastic. Okay, so don't write thermoset only. Okay, similarity, man-made. You are correct as well, right? Consists of carbon and hydrogen. Wow, I never thought of that, but that's correct as well. But wait, let me read again. Okay, usually like that, right? We write characteristics one. We go for this one. I'm not saying man-made is wrong and carbon, hydrogen, Jajun and Emilia's answer. But usually when we compare characteristics one, we compare this. Okay, so similarity, both are good electrical insulator, both are resistant to chemical such as acid and alkaline. Okay, yeah. Oh, I never thought of that answer though. You all did find out. So it both consists of carbon and hydrogen. Both are man-made. Okay, judging man-made a bit don't want a bit not so good. I mean, of course, it's like plastic confirm man-made. Okay, yeah, they consist of carbon and hydrogen. Yeah, so I was saying that I suggest you guys to write characteristics rather than this one. Okay, all right, so you guys okay? So good electrical insulator. Okay, okay, state one property for each. Okay, like you choose whatever you want. I don't know, choose from here, choose from here. Okay, you choose what you want. Okay, choose 了 Okay, like now this is something happens recent years, right? A lot of these kind of cases. Huh? Okay, anyway, these are plastics that tangle or stuck with marine animals, be it the turtles or be it other fishes. Okay, what step can be taken? Actually, nothing fancy to write. As simple as actually to recycle plastics, then it will not end up in the ocean. Yeah. Put dustbins. Actually, you all know all these plastics are. It could be from where we throw into rubbish bin, but in the process of going to the dump site, or it could end up in the ocean. So sometimes it's not what we do. Sometimes it's how they manage the waste. So I think that kind of answer a bit too far away. To solve this problem, okay, the best way is always to start from where we are. Okay, so I suggest don't go for too fancy answer. For me, I would just stick to what we have in your textbook, which is this one, which is to recycle the plastic waste. Okay, so I will go for that. Yeah, so I will write recycle and reuse plastic. Okay, yep. Burn in incinerator, that's to reduce pollution. Okay. The problem with all the rubbish ends up in the ocean, right? To solve that is not to burn them, it's to not continue use those kinds of plastics. Yeah. So a bit like open answer, but a bit not really, a bit restricted on what we need to write. Okay, so recycle plastic waste will be the accurate answer. Okay, burn in incinerator is more like how to reduce the air pollution if you really want to burn it. Okay, done with that. Okay, maybe we can one more, then we're done. And 28 for question 8 like question 8, last question about. Okay, so by seeing the names, you already know which plastic category they belongs to, right? So polythene, polystyrene, they belongs to thermoplastic. Melamine, bakelite, that belongs to thermosetting plastic. So above diagram, state one object that becomes soft and unchanged. Okay lah, becomes soft means thermoplastic. Unchanged means thermosetting plastic, right? Okay, so give one chin-cai up to you. You want to go whichever you want. Okay. Okay, can Okay, so I don't know, like polythene, polystyrene, then unchanged will be melamine and bakelite. Okay, it's up to you. Give an inference, like inference means why, right? Observation plus, sorry, my writing is very bad. Reason. Okay, so we have to focus on A2 only. Sorry, A2 only, this one. So ask yourself, why melamine unchanged? Or why melamine does not melt? Then you have to bring it down. That's your observation. Then only because, then your answer. Okay, so we have this on. Okay. It's unchanged because it's thermosetting. Okay, Emilia, that's what I want to explain already. So most of us, we would think, oh, why unchanged? Because it is thermosetting. That's not a correct answer. Okay, you remember there's this alloy question where the metal ball falls and create a dent. You remember this alloy in Form 4 Chapter 8? It falls and it creates a dent on pure metal, and alloy is not so deep, right? And then the inference asks you why, then you're like, because metal X is alloy. That's usually what we say, right? Why not so deep? Alloy, right? But when we write that answer for inference, we usually say why not so deep is because it is harder than pure metal. We don't jump to the conclusion yet because this is inference. So apply back to this. Why this one no melt? Why this one unchanged? So a lot of people will be thinking, thermoset law, right? But actually, you should talk about the cross link. Yeah, this is usually how people lose their marks. So, Emilia, you get the idea. So, for example, you say because it cannot melt, that's also not a correct answer. It does not melt is like saying this same thing. You are just saying the same thing. So, that's not going to give you another mark. So, we would say this does not melt, or melamine remain unchanged because of what? Because of the cross link. We have to talk about cross link. Okay, so after you write your first part, melamine remain unchanged, or melamine does not melt when heated, or melamine that remain unchanged when heated. Then we continue because. Okay, sorry, I show you how I write. There you go. Because it consists of cross linkages between the polymer, which makes it heat resistance. Okay, which makes it heat resistance. So the mark comes from cross linkages actually. Then if imagine the next question asks you, what conclusion can you make from the experiment? Then you say thermosetting plastic is heat resistant, or you can say melamine is thermosetting plastic. That's conclusion. Okay, you all copy from that, and after that you all can draw lines for C. Very easy. I'm not gonna talk about that. That's for you. Okay. Yay, cool beans. We are done with chapter 7, people. We have chapter 8 to go. That's for next week. So if you're done, and I will be seeing you next week for the next part. Okay. Bye, people. Have a good night. All right, welcome. Bye-bye. Bye-bye, people. Okay, bye. Bye.